I'm good.
So you're going to verbalize stuff tonight?
Yes.
Okay. And you're probably just reviewing everything for your final?
Yeah.
You're done with new material?
Yeah.
Okay. Go ahead.
So first problem is x, so it's remainder in factor terms. So the first polynomial is x cubed minus 10x minus 24.
What about it?
Divided by x minus 3.
Okay. I presume, do you know how to do long division?
Yeah.
Okay, let's do this by long division. What goes inside that?
X cubed minus 10x minus 24.
Notice that it's missing an x squared. You have to put in a dummy filler, is what it's called. 0x squared, like that. Then minus the 10x, then minus 24. Now we have every level of x inside the radical. It's not really the radical sign, but the divisor sign. Okay? Now what's the first step?
Bring up divide x cubed by x.
Perfect. What do you get?
X squared.
Second step?
And then multiply the x squared by x and negative 3.
Good. What do you get?
X cubed minus 3x squared.
Now you can kind of see why we got that dummy thing in there. Because you have to subtract these two now. Remember, long division, you're always subtracting. So what do you got? X cubed minus x cubed is 0, as it always will be. But what is 0x squared minus a minus 3x squared equal to?
3x squared.
Okay. Next step is always to bring down the next term. Now repeat. In other words, once you've done that first step, everything else is exactly the same. In other words, you're going to divide x into 3x squared. What do you get?
3x.
Plus 3x. I do need the plus sign.
Okay.
That answer is part of a polynomial. If I don't put a plus there, it would mean x squared times 3x. So that plus sign is very important. Now I multiply. Again, that is always going to be, whatever that is, that's what I'm writing right there. Assuming I've done my division properly, right? And then I multiply the 3x times the minus 3, which is minus 9x. Subtract those. What do you get?
Negative x.
What's the next step?
Bring down to 24.
Negative 24. And the next step.
So divide negative x by x.
What do you get?
0.
Oh, negative x by x. What is that equal to?
Negative?
Negative 1.
Okay.
Anything divided by itself. 7 over 7 is 1. 3 over 3 is 1. 117 over 117 is 1. So x over x is 1. Minus 1 because one of them is negative. So this is minus 1. Next step?
Multiply it.
Okay, so I didn't leave myself quite enough room here. Plus 3. Subtract those. What do you get?
Negative 27.
Now, notice that I can't do that division anymore. I can't divide x into minus 27. So what that means is I'm done. That's a remainder. And the way to write it, you could write it a couple of ways. I could say remainder of minus 27, but that's not really a good way to write it. Okay? What it really means is minus 27 divided by our divisor, x minus 3. So the answer is that polynomial minus 27 divided by x minus 3. That's the complete answer.
Okay.
Okay. Now, have they taught you synthetic division?
Yeah, but I still kind of don't understand it a ton.
Let's go over it. It's actually easier. Once you understand it, it's easier, and the reason is that you don't have to do subtraction the whole way. Although you're pretty good with subtraction, you didn't make a mistake on the subtraction. But what we do with synthetic division is we get rid of the x's. We don't need the x's, but we still need dummy variables. So here's what I'm going to do. What goes in the box?
So
Is it minus 3 or 3?
no, just 3.
3. It's the 0 itself. In other words,
Okay.
the 0, if x minus 3 equals 0, then x equals 3. So you always put what the actual 0 is in the box. Now across the top, you just put the coefficients. You don't put the x's. So the first one, that coefficient is 1. What's the second number I need to write?
So the second number would be 0.
Good. In other words, you still, just like with long division, you have to allow for every power of x. Third number, minus 10. Fourth number, minus 24. All line right there. Now, notice that we're going to do everything pretty much the same, but before we were dividing by x minus 3. Now we're doing synthetic division by 3 instead of minus 3. And what that allows us to do is everything is addition. It changes the subtraction into addition. First step always is to bring down that first coefficient. What's the second step?
Okay. Then multiply it by 3.
And write it right there.
Yeah.
What's the next step?
Subtract.
We're always doing adding. That's
Okay.
why we're doing synthetic division, is because it's easier, because you're always adding, you're not subtracting.
Okay.
Next step.
Multiply it by 3.
Next step.
Add.
What's the answer?
-1.
Next step.
Multiply by 3.
Next step.
Add to get -27.
Notice we got there a lot easier than it took us before. What does that 1 mean? That means 1x squared. What does the 3 mean? It means plus 3x. The minus 1 is right there, with a remainder of minus 27 divided by the divisor, which is x minus 3. So we get exactly the same answer. Only we're doing addition at every step, addition and multiplication instead of division and subtraction. And addition and multiplication is a whole lot easier than division and subtraction. So if you can do these things synthetically, it's worth doing it. And as you go into harder and harder math like this, you have to do this a lot. And so that's why they really want you to learn synthetic division. They even can call it synthetic substitution, which is basically the same thing. Not really. Synthetic division and synthetic substitution is pretty much the same. All right, you got another one?
Yeah.
What?
So the next is f of x is equal to x cubed plus 2x squared minus 9x minus 18.
And I want you to factor it.
Yeah.
Okay. We're looking at a cubic. Cubics are like quadratics on steroids. It's that much harder to factor. Okay. Quadratics you can always solve by applying the quadratic formula, right? So quadratics are actually a piece of cake. Cubics can be incredibly hard to do. A typical cubic that they ask you to factor might take 20 minutes to do. There is no cubic formula you can apply. Okay? Now, there is one type of cubic that can be done easily. And it's this. It's where you can group. In other words, if I can group those two terms together and I can group those two terms together, then I can make progress on this. And I'll show you why. And the reason you are able to group these, one thing has to be satisfied in order to group them. The ratio of the coefficients has to be the same. Well, in this first group, the ratio of the coefficients is 1/2, correct?
Yeah.
Second group, it's minus 9 over minus 18. Those two numbers are the same. That has to be true in order to solve this problem by grouping, which is this is the only cubic that's easy. All the others are 20-minute problems. But when you can solve it by grouping, it's not that hard. Okay, so here's what I'm going to do. I'm going to put parentheses around the first two terms, and I'm going to put parentheses around the second two terms.
Okay.
I want you to tell me what goes in both of those.
So first, it would be x.
What goes in the second set of parentheses?
So like 9x minus 18.
Now, I want you to compare the second line to the first line. If it's not the same, you've made a mistake.
Okay.
Is the second line the same as that function?
Yeah.
No, it isn't. This negative sign has to be applied to both terms. So if I remove the parentheses, I'm going to have minus 9x plus 18.
Okay.
So the fact that this is subtraction makes this much more difficult. Everybody in the world makes the mistake you just made. And the way not to make that mistake is when you're doing a problem like this, make sure you do not change it. When you go from one line to the next, you cannot change it. And the only thing that's not changed is if I make that a plus 18. Now, the second line is the same as f of x. If I want to remove these parentheses, I end up with f of x. Exactly. And that's very important, okay? Now, greatest common factor. Take what's in the parentheses on the left and factor out the greatest common factor. What do you get?
1.
What's the greatest common factor, first of all?
Oh, wait. Oh, 2. 9.
Not 2. You can't divide x cubed by 2. Greatest common factor has to be divisible into every term. So I can't pull a number out. Can I pull a variable out?
Yeah.
What?
X.
X squared.
X squared.
What's left over?
X plus 2.
Good. What can I pull out of this one?
9.
What's left over?
X plus 2.
If these two things aren't the same, you're not going to be able to solve it by grouping. They have to be the same. Had you made that mistake where you had it minus 18, then this would read x minus 2. Not the same as x plus 2. That tells you one of two things. You've made a mistake or it can't be solved by grouping. But to be solved by grouping, what's in the parentheses has to be the same.
Okay.
Now, the next step is an unusual step if you've never done it before. You're used to factoring out single terms. When I ask you about greatest common factor, you factored out an x squared. That's a single term. When you factored over here on the right, you factored out a 9. That's a single term.
Mm-hmm.
But now, what can we factor out of this whole expression? What is divisible into both terms? X plus 2, which is a binomial term. You're not used to factoring out binomial terms. What's left over?
X squared minus 9.
Beautiful. That's how it works.
Okay.
That's not fully factored, so I haven't really solved it. Because I can factor x squared minus 9. What is that equal to?
X plus 3 and x minus 3.
Now you've got your three solutions. We're going to set this whole thing equal to 0. What are my three solutions?
So x is equal to x plus 2.
Hold on. We get our solutions by setting each of these linear factors equal to 0. So when I say x plus 2 equal to 0, what's x equal to?
X is equal to negative 2.
When I said x plus 3 equal to 0, what is x equal to?
Negative 3.
And when I said x minus 3 equal to 0, what is x equal to?
X equals 3.
Those are your three solutions. And when you have a cubic equation, you expect three solutions. If you have a quartic, you would expect 4 solutions. When you have a quadratic, you expect 2 solutions. So you almost always have the same number of solutions as you have the highest degree of the equation. In other words, if you find yourself doing cubics and you only come up with 2 solutions, you've left one out.
Okay.
Okay? In other words, you can't stop at that step right there. You got to factor it all the way down. So I had to factor the x squared minus 9 also to get to that step. Now I can solve it. Okay? Jonathan, I will let you go.
Okay.
Talk to you next time. Have a good rest of your evening.
You too.